So keep in mind that if I decided I wanted to multiply both sides of an equation by 7, the equation still remains balanced. Or if I want to add 5 to both sides of the equation, it still remains balanced. And likewise, if I decide I want to take the log of both sides, it still remains balanced. And so the reason that I might want to do this is to help bust up some of this stuff. Of course, I could have taken the derivative of this problem without natural logging both sides, but it would have been a little messy. And I'm going to show you that at the end, after I show you what happens when I take the natural log of both sides. So of course, on the left side, if I want to take the derivative, I get 1 over y dy dx, because I am taking the derivative of this entire equation with respect to x. And of course, this 1/3 is allowed to sit down in front. And since I have a quotient, I would be splitting this up into a subtraction problem. So I would have the natural log of x squared plus 1 minus the natural log of x squared minus 1. So now, got a little squished here. I'd fix it. So now when I take the derivative of that right side, I'll have 1/3. And then on the inside, for the first piece, I'll have 1 over x squared plus 1 times the derivative of the stuff, and then minus the second piece will be 1 over x squared minus 1 times the derivative of the stuff, which is 2x. And so I'm going to simplify the right before I do anything with the left. I'll just leave the left alone for a minute. So I'll have 1/3 and then 2x over x squared plus 1 minus 2x over x squared minus 1. Okay, so now, of course, I can get a common denominator and put those together. But then ultimately, since I want to get the derivative, I'll have to multiply both sides by y to get rid of that 1 over y. And so y prime equals, I don't want the y to be in there because I want everything in terms of x. So I have to remember, well, what was y? And so y, all the way back to the beginning, was that cube root. And